This is video 1B, and this is our skills review part 2. All right, and so today we're going to be focusing on exponent rules. All right, so first of all, remember when we multiply, you always treat your coefficients normally. So we're going to multiply our 3 times our 2, which is 6, and when you multiply, you add exponents. So this is going to be x to the 7th. All right. When we divide, we subtract our exponents. So go ahead and treat your coefficients the same. 8 divided by 2 is 4. And x to the 5th minus x to the squared would be x cubed. All right. And there's nothing in our denominator, so we can just keep it written like this. When we square an object, okay, it means we are squaring everything inside the parentheses. So what this means is this is actually 3 squared and x cubed squared. All right, so 3 squared is 9. And with this, a power to a power, you are going to multiply. So this is going to be x to the 6th power. Okay, so just kind of a little note is when you multiply, you add the exponents. When you divide, you subtract the exponents. And a power to a power, you multiply. Okay, so those are just kind of a little hint that hopefully will help you. All right, moving on. In here we've got a power to 0. Remember, anything to the 0 power is 1, okay? And let's just take this kind of step by step. So first off, we've got our 5y, nothing's happening to that. We're gonna take our 3 cubed, and y to the 0 is just 1, and so this would be 1 cubed. 3 cubed is 27. 27 times 5 is 135. And we just have 1y. All right, again, we've got a fraction squared. So everything in that fraction you are going to square because the parentheses are around everything. So this is 5 squared and 9 squared, which is, go ahead and reduce that, or simplify to 25 over 81. With our negative exponents, we don't like negatives. They're not proper for mathematicians, so we're going to kick them down to the bottom. Remember, everything is a fraction because it can be written over 1. Okay, so we're actually going to kick that down to the bottom, so it'd be 1 over 4y squared. And then we're going to simplify our denominator. 4 squared is 16, and y squared is y squared. Okay, with our fractional exponents, if I have a fraction a over b, if I want to rewrite that as a rational, my denominator becomes my root, and the numerator becomes the exponent. So I like to think of it, if it's on the bottom, it gets kicked out to the front. If it's on top, it stays on top. All right, so here we have 16 to the power of 2/3. So this becomes the 3rd root of 16 squared. And those parentheses are, yep, that's right. All right. And so we can go ahead and we can simplify that if needed. For right now, we'll just keep it as is, just for simpler sake. Okay, moving on, when we've got radicals, we need to go ahead and do some prime factorization, okay? So let's find out all the prime numbers for 40. That would be 4 and 10. 4 would become 2 and 2. This would become 2 and 5. Okay, remember we are looking for groups of 2. So there's a group of 2. Those become on the outside, and then we multiply what's left over and it stays in the inside. Okay, 4 is a perfect square, which is why we get a 2 on the outside for that. Okay, with our next one, 112, let's see, that would be 8 and 14. Okay, and you guys can come up with any numbers you want for there as long as they multiply to 112. We're going to kind of skip a step because I know that 2 times 2 times 2 is 8. And 2 times 7 is 14. So I actually have 2 groups of 2 that just happen to be 2s. Lots of 2s over here. Okay, so on the outside I still have my 3 times 2 times 2, square root of 7. And let's see, that would become 12 square root of 7. Okay, if I had a cube root of 112, okay, we would do the same factorization. So I'm just going to go ahead and write this last step. 2, 2, 2. And because it's a cube root, we're looking for groups of 3. So this would be our group of 3, and this would be 3 square root, or I'm sorry, 3. All right, let's try again. This would be 2 cube root of 14. All right. Now our next section is rationalize the denominator. Mathematicians are pretty picky on how they like things written, and we do not like square roots or any sort of root in our denominator. Okay, so we're going to rationalize it by multiplying by itself in the numerator and denominator. So we would multiply by a square root of 5 on the top and bottom, and that would become 8 square root of 5 over 5. Okay, square root of 5 times the square root of 5 would become square root of 25, which is simply 5. Okay, if we did the same here, we would have, we'd be multiplying by the square root of 15, and so we'd get 15 in our denominator and square root of 75 on top. Okay, we can reduce this even further by saying 5 square root of 3 over 15, which reduces yet again to square root of 3 over 3. All right. A conjugate is when you have a two-term expression, you switch the positive to a negative. So if you have a plus sign, make it a negative. For example, x plus 2, the conjugate would be x minus 2. We need to use the conjugate if you have a rational in the bottom that's being added or subtracted by something. So when you multiply by the conjugate, okay, what this would turn into is you would distribute the top, so we'd have 16 minus 4 square root of 2, and in the denominator we would distribute, and just by our double distribution, and it gets a little messy, but persevere with it. Okay, and if you can look, our two rationals or radicals cancel out, okay? So then we have 16 minus 2, which would be 14. All right, this one's kind of a long problem. But because all three of these numbers, 16, 4, and 14, are even, we can reduce this. We can simplify it a little bit more. I can divide by 2, so I get 8 minus 2 square roots of 2, anything under a radical stays, divided by 7. All right, our very last part, this is just kind of a really brief overview, is graphing our radical functions. These are some things that we'll run into. So remember, a whole is when you can cancel a factor from the denominator and numerator, and you're just going to set that equal to 0. Your vertical asymptotes, you set your denominator equal to 0 and solve. Horizontal asymptotes is where things get a little tricky. Okay, it's always our numerator degree versus our denominator degree. So if the numerator is less than the denominator, your horizontal asymptote is 0, y equals 0. If it's bigger, you don't have a horizontal asymptote at all. And if they're equal, you're going to take the ratio of their leading coefficients. All right? Okay, so that's just kind of a brief overview over graphing radical functions, rationalizing the denominator, and a few exponent rules.